Have you ever stopped and thought about this? Your phone shows your location in seconds. Your car knows every turn. And a ship, surrounded by nothing but water, knows exactly where it is. No landmarks, no signboards, just open ocean. So how does that work? The answer is GPS, the Global Positioning System. GPS is not magic. It is a smart system that tells us our exact position anywhere on Earth. It works using two things: satellites high above us in space and a small receiver right here on Earth. Let's break it down, step by step. Far above the Earth, thousands of kilometers in space, more than 24 GPS satellites are constantly moving around our planet. They follow fixed paths and never stop. Each satellite knows two very important things: its exact position in space and the exact time, down to a fraction of a second. Every second, these satellites send radio signals down to Earth. The signal carries where the satellite is, that is, the position, and the exact time the signal was sent. These signals travel incredibly fast, at the speed of light. Down here on Earth, we have a GPS receiver. It could be your mobile phone, your car's navigation system, or a ship's GPS on the bridge. The receiver does not talk back to the satellites. It only listens. Now here's the clever part. GPS works using a very simple idea. If you know how fast something travels and how long it takes to reach you, you can calculate the distance. Your GPS receiver checks the time the signal was sent and the time it was received. The difference tells the receiver how far away the satellite is. One satellite gives only one distance. That still leaves many possible positions. So the GPS receiver listens to many satellites at the same time. Each satellite narrows down the possible location. When signals from 4 satellites are received, the GPS can calculate your exact position on Earth, your height above sea level, and correct its own clock error. This method is called trilateration. 3 satellites give position, the 4th makes it accurate. Of course, GPS is not always perfect. Accuracy can reduce because signals slow down in the atmosphere, signals reflect from buildings or mountains, or satellites are not ideally placed in the sky. That's why ships often use DGPS, or differential GPS system, which improves accuracy even further. DGPS works with the help of a tower on land that continuously transmits the correction data. The principle of operation of the tower is simple. It knows its own exact position versus the position received from GPS signal. The correction data is then transmitted. On ships, GPS is used every moment to know the ship's position, to calculate speed over ground, to find course over ground, and to feed position into navigational and communication equipments. But there is one golden rule: never trust GPS alone. A good navigator always cross-checks GPS using radar, visual bearings, echo sounder, and paper or electronic charts. Because when technology fails, seamanship takes over. Remember this: GPS is a powerful tool, but safe navigation depends on the human watchkeeper. Understanding GPS matters far more than simply pressing a button.
It takes a lot of effort to make these videos. You can help us by subscribing us.